Good morning. So in previous sessions, we have seen that how to estimate the time delay. And now let us see the concept of ring oscillator. What is ring oscillator? How it is constructed? What for ring oscillator? Like that. The purpose of ring oscillator is to measure the time in terms of nanoseconds. It is very difficult to measure the nanoseconds time period using oscilloscopes. That's why an alternative approaches we have to follow. One of the method is ring oscillator concept. By using the ring oscillator, you can estimate the delay in terms of nanoseconds. Now what is ring oscillator means? The ring oscillator is a cascade connection of odd number of inverters. The slide representing the ring oscillator consists many inverters in the cascading connection, but the number is odd always. And the output of the last inverter acts as a input for the first inverter with the positive feedback. So that what happens, it acts as an oscillator. In oscillator case, the feedback type is positive. Okay. Let us consider a three-stage ring oscillator. That is, the number of inverters are 3. With reference to 3 stages, let us see the waveform with reference to the outputs of each and every inverter. The first one represents the output of first inverter with output variation, whereas the second waveform represents the output voltage variation with reference to second inverter, whereas the third waveform represents the output voltage variation of third inverter. Okay, so coming to VA, when the VA voltage changed 0 to 1 and it is acts as the input for the second inverter, its output changes as 1 to 0 because it is an inverter, and VB acts as the input for the third inverter so that its output changes from 0 to 1, but proper delay with all these happen, right? And those delay also represented in the bottom here. This is called TDR1. TDR1 means the rise time delay. The rise time delay with reference to first inverter. TDF2, that is the fall time delay with reference to second inverter. TDR3, the rise time delay with reference to third inverter. TDF1, the fall time delay with reference to first inverter. TDR2, the rise time delay with reference to second inverter. TDF3, the fall time delay with reference to third inverter, and TDR1, the rise time delay with reference to first inverter, like that. Okay, the first one is repeated again. So with reference to this diagram, the time period consists 6 number of time delays. The 6 number of time delays that you can write in terms of transition propagation delays like this: T equal to TPHL1 plus TPLH2 plus TPHL3 plus TPLH1 plus TPHL2 plus TPLH3. So rising means LH, falling means HL, like that. Okay, so from the above waveform, you can write in terms of low to high, high to low propagation delays like this. And now group the above times like this: TPLH1 plus TPHL1 is one group, TPHL2 plus TPLH2 is one group, and another group is reference to third inverter, the TPHL3 plus TPLH3 times. And previously we derived the time delay of each gate is the average of transition propagations, right? So therefore, the sum of TPLH1 plus TPLH2 is equal to 2 times of TD. Similarly, with reference to second inverter, the sum of these two times is equal to 2 times of Td. Similarly, with reference to third inverter, the delay is 2 times of Td. So that it is equal to the time period of this 3-stage ring oscillator is equal to 6 times of Td. And you can write this as 2 into 3 times of Td, where 3 is number of stages. Where 3 is the number of stages. Suppose if you maintain n number of stages, how much time period you can expect? Very good. That is 2 times 2 into ntd. Okay. So in case of n stages, the time period you can express as 2 into n times of td. And now this is the time period. Therefore, the frequency of oscillation you can express as f equal to inverse of the time period, that is 1 by 2 ntd. Therefore, the delay td equal to 1 divided by 2nf. So by knowing the ring oscillator frequency, you can estimate the time delay. Okay, so like that you can measure the time delay in the technologies. If the time delay in terms of nanoseconds case, this ring oscillator is very helpful to measure the time delays. Okay, thank you.